Check out this triangle right here. We're given angle B as 45 degrees and the side B, opposite of angle B, as 20. We're also given angle C as 105, but not the length of C. And we're not given angle A or the length of side A, which is opposite of angle A. When you're given a triangle like this and it's not a right triangle, we could use law of sines to solve the triangle or find the missing angle and the sides. Here's the formula. Again, given triangle ABC with side A opposite of angle A and also side B opposite of angle B and side C opposite of angle C, the formula is sine of A over side A. We're going to set that equal sine of B over side B, and we could also set that equal sine of angle C over side C. Let's go ahead and use that formula on this particular triangle right here. So what we could do is we could go ahead and say sine of 45 degrees, the given angle, set that over 20, again, the side opposite of that angle, and we're going to set sine of 105 over the side C, which is opposite of angle 105. Then, to complete this, or to solve for side C, we'll go ahead and cross multiply. What we get? C times sine of 45 degrees equals 20 times sine of 105. Then finally, to solve for C, what we can do is divide it by sine of 45 on the left and also sine of 45 on the right in order to get rid of that sine of 45. Here C is approximately equal to 27.32, rounded off to 2 decimal places, once you put that 20 times sine of 105 over sine of 45 in the calculator. Next, take a look at the triangle. If we have 105 and 45, we could take the 180, because 3 angles of a triangle add up to 180, and set it equal 105 plus 45 plus measure of angle A, where measure of angle A will equal 30 degrees, right here. Then, using the law of sine, once again, we could set up this equation where we have sine of 45 over 20. Again, 45 over the opposite side, which is 20, as we had it before. We're going to set it equal sine of 30, measure of angle A, set it equal over, or sine of 30 degrees over side A, which is again opposite of angle A, or 30 degrees. To solve for angle A, let's go ahead and cross multiply like we did before, like this, where we get A times sine of 45 equals 20 times sine of 30 degrees. We'll go ahead and divide it by sine of 45 on the left and also sine of 45 on the right. And then we'll go ahead and cross out sine of 45, where we have A approximately equals 14.14, once again rounded off to the 2 decimal places. So this is a basic example of a triangle where it's not a right triangle, where we don't have angle or the sides, where law of sine comes in handy. Notice that in this triangle, we're given only 1 angle instead of 2. However, since we're given an angle and also the length of the side opposite of the angle, we're able to use law of sine to solve this triangle. And here's the equation that we want to use. Sine of 42, the given angle, over 22, which is opposite of angle 42, equals sine of B, which we don't know, over the side opposite of angle B, which is 12. Again, we could go ahead and cross multiply, where we have 12 times sine of 42 equals 22 times sine of B. To solve for B, we're going to go ahead and divide it by 22, left and the right side. where we're left with sine of b on the right side. And if we plug in 12 times sine of 42 over 22 into a calculator, we get 0.365, once again rounded up to 3 decimal places. Finally, to solve for angle B, we need to go ahead and use the inverse sign. And it's going to be inverse sine of, what happens is that we swap the angle B with 0.365. And if we plug in, once again, inverse sine of 0.365 in the calculator, we'll get B equals 21.41 approximately, once again, rounded off to 2 decimal places. So we'll go ahead and write down that angle B right up here is 21.41 degrees. Then to find angle C, we'll once again use that 3 angles of a triangle, add up to 180, where we have 21.41 for the measure of angle B, and 42 for the measure of angle A, and then angle C, where if we solve for angle C, put this in the calculator, we'll end up getting 116.59 degrees. So let's go ahead and use the law of sine to find our side C, where it's going to be sine of 42 degrees over 22, pretty much the same thing that we set up earlier. And we're going to set that equal sine of angle C, which is 116.59 over side C. Let's go ahead and cross multiply, where we get C times sine of 42 equals 22 times sine of 116.59. We'll go ahead and divide it by sine of 42, left and the right side, so that we could get rid of sine of 42 and solve for C, which equals 29.4 inches as our final answer. So there you have it, folks. So the first example was where we were given 2 angles, whereas the second example, we're given only 1 angle to find rest of the triangle. With the previous 2 examples, we were actually given the drawing or figure of the triangle. However, in this example, we're only given side A, side B, and angle A, and most importantly, there's no triangle given. So in this case, the first thing we have to figure out is if a triangle exists with this kind of information. Let's go ahead and draw the triangle ourselves. We'll go ahead and draw our generic triangle ABC. And what we want to do is draw an altitude like that. And let's take a look at this triangle on the left, where side B is given as 25, and side A, by the way, is 15. Angle A right here is 85 degrees. So what we'll go ahead and do is use our sine formula to write down sine of 85 equals, and then we'll let this be h for the altitude or height of the triangle, h over the hypotenuse, which is 25. Once again, we're focusing on the triangle on the left, where if we multiply by 25 on the left and the right side of the equation, we get h equals, let me go ahead and do that on the calculator, 25 times sine of 85 is 24.9, or rounded off to 1 decimal place approximately, of course. So if height is 24.9, then take a look at this triangle on the right. Notice that the hypotenuse is 15. And the hypotenuse of a triangle has to be the longest side of a right triangle. However, for this right triangle on the right side, the hypotenuse is less than the altitude or the side of the triangle, which is impossible. Remember, hypotenuse has to be the longest side, which means with the given information, this triangle does not exist. Here's another way. What we could do is we could set up this equation using the law of sine. So we'll start with sine of 85 over 15, which is opposite side, equals sine of b, that we don't know angle b, and then we'll set that over 25, which is opposite of angle b. Then we'll go ahead and cross multiply, where we get 15 sine of b equals 25 sine of 85. And then we'll go ahead and divide it by 15. Then we get sine of b equals, again, let me go ahead and pop that in the calculator. And that's going to equal 1.66. However, sine of an angle, the maximum value is 1. Remember, sine of any angle has to be less than or equal 1. You have to keep that in mind. Since sine of angle B equals 1.66, which is more than 1, you know this angle B cannot exist in this triangle. So there you have it, folks. Here's an example where if you're not given the figure of the triangle or the drawing of the triangle and given just the numbers, you have to go ahead and use this example here to figure out if the triangle exists before solving the triangle. Of course, there are two ways, as I showed you here, using the right triangle on the left and the right here as the first method, or you could just go ahead and set up the law of sine directly and solve for sine of b. And if the sine of b is more than 1, then the triangle doesn't exist. Here's another case where we're given the information or partial information about the triangle, but not the drawing or the figure of the triangle itself. So let's go ahead and draw the triangle ourselves, where it's going to look like this. Then, first thing we want to do is find out if this triangle exists. So we'll start by saying sine of 42 over 22, again, opposite of each other. We'll go ahead and set that equal sine of angle B over the opposite side, which is 12. Then to solve for sine B, we'll go ahead and cross multiply, where we get 22 sine B equals 12 times sine of 42. And to solve for sine of B, we'll go ahead and divide left and the right side by 22, where sine of B will approximately equal, I'm going to do that on the calculator, it's going to be 12 times sine of 42 over 22, and that equals 0.365, again rounded up to 3 decimal places. Since the sine of angle B is less than 1, we know that this triangle does exist. The next thing that you want to figure out is if this is a 1 triangle case or a 2 triangle case. So 2 triangle case I'm going to be showing you in our next example. However, if the side opposite of the angle that's given is more than the side on the left side, or side opposite of the angle that's not given is greater. Again, if this side is greater than the side on the left side or opposite of the angle that's not given, it's always going to be 1 triangle. This is pretty important. Again, first you check if the triangle exists, which we did, and to find out if it's a 1 triangle or a 2 triangle case is that if the side opposite of the angle that's given is greater than the side opposite of the angle that's not given, it's going to be 1 triangle. So in my next example, let me show you how or where you would get 2 triangles given 1 set of information. So here's a case where we have 1 set of given information. However, with this 1 set of information, we're able to find 2 different triangles. Here's what I'm talking about. Let's go ahead and draw the triangle ourselves since it's not given by the problem. With the given information, let's go ahead and assume that we checked and that this triangle does exist. Check out the side A, which is 12. Notice the opposite side of the angle that's given, meaning the 12 is less than the side opposite of the angle that's not given. In the previous example, the side opposite of the angle that was given was greater. However, this time it's the other way around, where the side opposite of the angle that's given is less than the side opposite of the angle that's not given. The reason we get two separate triangles is because the side BC that we have here, or the side A, the 12, it could swing around like this and end up giving us a triangle looking like this. Once again, if you look, this side right here, it swings around to the left and it ends up giving us a triangle looking like this. Notice that side B is 31, angle A is 20.5, and side A is 12. All the information that's given by the problem is the same for both triangles. Only difference is that angle B here, it's acute, meaning it's less than 90. But again, if this side swings around to the left like this, then we end up getting angle B as an obtuse angle. Hence, we get two separate triangles. So when you're using law of sine, if you're given the triangle figure or the drawing is given, there's no ambiguous case, meaning there's always going to be that one triangle. But if you're given just the numbers, meaning the information about the triangle and not the figure or the drawing of the triangle, we get these ambiguous cases where the triangle could be not possible, meaning no triangle, or as in the example just before I showed you, where it's one triangle if the side opposite of the angle given is bigger than the side opposite of the angle not given. Again, if the side is bigger, it's one triangle. However, if the side opposite of the angle that's given is less, just like here where 12 is less than 31, you get two triangles looking like this. Let's go ahead and finish this up by solving the triangles, both of them. First of all, we're going to go ahead and use the law of sine to set sine of 20.5 over A, which is 12, equals sine of B over 31. And we'll go ahead and cross multiply, where we get 12 sine of B equals 31 sine of 20.5. We'll go ahead and divide that by 12, where we get sine of B equals, here we go, calculator, 31 times sine of 20.5 over 12, and it gives us 0.9047. Again, this is approximately, right? Round it off. And then we'll go ahead and take the inverse sine of 0.9047, and we'll set that equal angle B, where B will equal, if I take the inverse sine of that, and I get 64.78 degrees. So angle B right here will be 64.78 degrees, and always round it off to two decimal places. Then we can go ahead and find angle C by subtracting angle B, 64.78, and also 20.5, and using the law of sine again to find side C. Now, what about the second triangle? How do we find this angle B? Well, we can go ahead and set up the law of sine once again. However, here's a better way. The second triangle, we'll call it B2, will always be supplementary with B1, or the first angle that we found. So B2, you can simply take 180, subtract the first angle that we found from the triangle right here, subtract 64.78, where B2, or angle B of the second triangle, will be 115.22 degrees. Again, angle C, we could go ahead and take 115.22 and also 20.5 subtract to find angle C, and use law of sine one more time to find side C, which will be different from the side C of the first triangle. So there you have it, folks. Law of sine is quite simple and it's easy to use if you're given the picture or the figure of the triangle because it's going to be that one triangle. However, if you're not given the picture of the triangle, then that triangle may exist or may not exist. That triangle may have one possible triangle, or as in this case, you could have two possible triangles. Again, if the side opposite of the angle is smaller or less than the side opposite of the angle that's not given. And another key is that once you find the first triangle or the angle of the triangle, the same angle of the second triangle can be found by subtracting it from 180 because the first triangle, angle B, that's not given, and B2 or the second triangle are going to be supplementary.